So as you may know, energy, work, and power are one of the most important things in our current world, because we need energy to turn on a light bulb. Not a very good artist. Okay, we also need energy to we get energy from a dam, with water flowing through it. I'm a horrible artist. All right. And in these several videos that I'm going to go over energy, work, and power, and the fact that energy is, or any other sorts of energy, we have two sorts of energy. We have kinetic energy, kinetic and potential energy. Okay. And kinetic energy is basically energy associated with the motion of an object. Okay. And I'll go into more detail into that in the next video. And potential energy is, for instance, say we have a bike. All right. Again, I am a horrible artist. Say we have a bike on top of a hill. All right. And the bike is 10 newtons, and it is 10 meters. Okay, 10 meters from the ground, or from sea level. Okay, so 10 newtons, it's 10 meters from the ground. All right, and so the potential energy is that it has the potential. Well, I'm just going to say that it has the potential to fall down these 10 meters, which gives you the potential energy. You can also hold a pole. Say, I'm holding a pole, and it's, maybe it's some distance, some arbitrary distance from the ground. It has potential energy to fall to the ground. So it has potential to fall to the ground. Okay. Also, work. All right. Work is just energy transferred to an object from an object as a result of the action of an external force. Okay. So say we have a block here, and we have a force being pushed on it. Okay, and it's going some arbitrary distance. Okay, so work is simply, force times distance. All right. Now the thing about work is that it is a scalar. All right, and it is not in any means a vector. Okay, so get that out of your head right now, that work is going to end up becoming a vector. All right, so it's a scalar product of the force vector and the displacement vector. All right, D can be a displacement vector as well, so it's going to be a scalar product of those two. All right, and the fact that the change in kinetic energy is due to applied force is equal to the work done by the forces. All right, so this kinetic energy is equal to the work done by the forces. Alright, so I will be defining that in the next video and proving it to you that kinetic energy is the work done by the forces. Alright, and next we have power, which is simply, I'm going to go down. Alright, oops. Computer freezing. Okay. Alright. So power is simply the rate at which work is done. All right. So power is the rate at which work is done. All right. So now I'll be defining this power in a much later video, after I define kinetic potential energy, and after I define work, we can then go into power. Okay, and that's all I really want to talk about in this video. The next one, I'm going to be proving to you kinetic energy and how to get that value of kinetic energy is equal to 1/2 times mass velocity squared.